In exercise 5, we're going to start to use this new method for solving exponential equations and combine it with the word problems we did earlier in this packet. The money in your bank account, which is currently $527, decreases by 4% each month. Write an exponential function that models this situation. So we know our basic exponential growth and decay formula is P times 1 plus R to the T. So the start value is 527, or the P, and I'll write that up here just because it's been a little while. And then our R, we're decreasing, so that's a negative 0.04. Writing out this function, we're writing our exponential function. Oftentimes, instead of y, we have a of t. That's how I'm going to write it here. So the amount after t, and in this problem, it's months. So I'm also going to write that t is months. So the amount after t months is 527 times 1 minus 0.04. So I'm adding a negative or subtracting, so that's 0.96 to the t. So the next problem now, we're able to do this algebraically. Algebraically determine how long will it take until you only have $100 left in the account. So fixing some grammar here, algebraically determine how long it will take until you only have 100 left in the account. Round to the nearest month. So I'm trying to get down to 100. 100 is an amount, so I'm saying the a of t, not the time, we don't know the time, that's what we're looking for. A of t is 100. So I'm setting my equation equal to 100. Now, before, we did do this a little bit in the regressions lesson, where we would go and we would look in our tables, we could graph the function and look for where the y value got to 100. Here, now that we can solve algebraically, we know we first have to divide by 527. I'm going to keep that whole decimal in my calculator. So I'm going to write down, it's approximately 0.19, but really it's 0.18975 and so on. Was 0.96 to the t. We see that that's our Venn form. Our base is 0.96, exponent is t, our number is 0.19, and we're going to change it over to log Benny so that we can type it in our calculators. So this is log, the base is 0.96, the number it's equal to is 0.19, and that equals t. When I type this in my calculator using my log base button, I'm going to highlight, once I get over to this spot, I will highlight that whole decimal above to get the exact answer. And if I type that in, so log base 0.96 of 0.18975 and so on, to the nearest month, I get 40.7, so that's going to be 41 months. Looking at the next one, it's very similar. It says the population of elephants in Africa is currently 497,000 and is decreasing 6% per year. If the trend continues, in how many years will the population of elephants be? And this should be 300,000. I just missed a zero there. So here, we're going to write out our function first. Our start value is 497,000. We are decreasing by 6%, so 100 minus 6%, or 1 minus 0.06 is 0.94. We're looking for the years, and we're trying to say, when does it reach 300,000? So in this problem, I kind of skipped writing out the function and went right to the equation. So from here, we would divide by 497,000. Once again, remember I added this zero. That was a typo in the lesson. And that's going to give me approximately 0.60, which is equal to 0.94 to the t. And then we're going to put it in log form. So my base is 0.94. The number it's equal to is 0.60, and that equals t. When I type that in my calculator, this time I'm going to the nearest tenth of a year. I should have mentioned in the beginning 6% per year, so the t is years in this problem. And that ends up equaling to the nearest tenth of a year, 8.2 years for the population to decrease down to that amount.